Hello everyone, my name is Karan. I'm a DevOps engineer. Um so yes, so welcome to my channel. Uh, so this video is about the Prometheus. This is my second video. I have already created one theoretical video which was about the Prometheus architecture, and it was a deep dive video. That was a theoretical one. If you haven't watched it and if you want to watch the setup, then this is video for you. But if you want to know like what Prometheus is, then I think you should watch the first video. I think you can also get the link on the I button as well. So the agenda for this video, this is the practical video. I will show how we can like the what are the various options of installation and setup for the Prometheus into Kubernetes. Then the setup Prometheus and Grafana using the Helm charts. That's the most easiest and a good and the recommended one. I'll also discuss the configuration, like the manifest for file for the Prometheus and for the Prometheus operator as well, and the Grafana and the Prometheus UI. This will also deploy the Grafana as well. In the part two, I will show how to set up the binaries. Let's say if you want to monitor. So this is about like the Kubernetes, but if you want to have any other URL or any server, if you want to, so I'll just give you information about that as well in this video. Okay, and this is not going to be a very long video. I just want to make it a short and a crisp one. Okay, so let me just quickly take you to the architecture first. So this was the architecture which was discussed in the earlier video, the Prometheus server, and this video is majorly focused on the Prometheus server and alert manager and this web UI and the Grafana part. Okay, so now there are multiple ways of deployment. The Prometheus server today will be focusing on the deployment. So we are deploying it on the Kubernetes to monitor the Kubernetes cluster, and as well as if let's say if we have an application running on that, I'll show you how you can change. You can do the configuration of that, as well as if you want to monitor the Kubernetes cluster as well. So the both will be covered in this. So first of all, before that, I have set up uh, a master node and a worker node. I have already installed the Kubernetes cluster using the kube ADM. I have steps with me. If you guys want the steps, I will add under the in the description. It's a very I'm just gonna this is not like the part of this video, but I'm just gonna quickly explain it. So in this section, I'm just installing the kube ADM, kubelet, and kubectl. All these are just the prerequisites. So this has to be run on both the master and the worker node. Then the container deconfiguration. This is also for both the master and worker nodes. You just need to copy paste the commands, and I've already tested it, and it will 100% surely works. The most important thing is the system C group, which is just changing the value from false to true, and the certain other commands. Then for the kube cluster initialization, this is just to run on the master node, and in this we are just initializing the kube ADM, the pod network, just copying the kube config file, and then this command needs to be run on the worker node. Yeah, when you like run this commands, you will get a join command, and you have to run that command on your worker node, so that worker node will be able to join the cluster. Now I'm using the Calico network, and that's the apply, and then the further the ingress. That's it for the Kubernetes setup. If I will show you on my let me just like go here, and it's already clear. So kubectl get nodes. You see here, one is the control pin and there is the worker node. It's already ready for me. Okay. Now if I just go here, okay. So now, yeah. So the first thing which I want to discuss is there are multiple ways where we can set up it. So the first way would be the manual way. It's like a create all the configuration files. So this website I got on the internet, so that's I'm just the showing it. So the first way would be to get all the configuration like manifest files of the Prometheus and Grafana, and use the kubectl and the other kubectl utility to deploy them manually. So that would be a very because Prometheus is a very uh, it has a lot of components. It's a very big tool, so there are a lot of configuration files required. So, and to do the manually is a very tedious task, and you have to do it in the right order as well. If you know it, then you can do it, but this is a very complex thing, and it's not recommended as well. The other thing is to do with the help of the Prometheus operator. Now, operator is a way to manage the Prometheus individual components, like the deployments and the stateful sets in the Kubernetes. They manage their pods. In the same way, operator will keep an eye on the combination when the deployment and the stateful sets, they both work with each other. So the operator will keep an eye on that, so that the Prometheus stack would properly run. So to monitor it, we need the operator. This is so for this part, this in this also there are the manual efforts are required, because we need to arrange the Prometheus operator in the Prometheus configuration files, and we have to deploy the the manifest files manually with the on the Kubernetes cluster. So that's also very complex, but the most the recommended way is doing with the Helm chart. I have the proper documentation for that. If I take you, so this is the documentation. This is the Prometheus operator. It's available on the GitHub. If you, I mean, so there are like multiple ways to do that. Either you can use the Prometheus operator, so it's part of the Helm repo, and then you can use the Cube Prometheus or the community help chart. Now, what all are these three? Okay, let me just explain. So let's start with this Cube Prometheus. Okay, so this Cube Prometheus, it's like a one-stop shop for Kubernetes monitoring. Okay, when you deploy this stack, okay, it deploys like the complete monitoring solution. It deploys your Prometheus, your alert manager instances, your like node exporter and cube state matrices, everything. Like it's a complete package specifically designed for the Kubernetes, and it will like run quickly and give you I mean your infrastructure is ready to be monitored. Okay, so this is the Cube Prometheus. Now, what is the difference between this and this Prometheus operator? So this Prometheus operator is more like a toolkit. It's not a comprehensive. It's like to managing the Prometheus and other instead of like bundling everything together like we did in the Cube Prometheus. In this, basically, it allows you to manage and deploy the Prometheus and other components separately, but it uses the custom resource definitions. This basically gives you more control and flexibility on how you configure and manage your monitoring stack. And you can also choose your components which you want to deploy and how they are configured, how they interact with each other in this. So this is the basic difference between these two, and this the Helm chart. This is just a Prometheus. I mean, which is managed Prometheus charts, which are managed by and these are Helm charts which are managed by the Prometheus community. So today, the major focus we don't would be on the Cube Prometheus, because it's a comprehensive solution, and that will, I think, enough for our need as well. So if I just take you to the documentation of it, I have like already note down all the commands. I will, as I already mentioned, I will paste these in the description as well. So this thing is nothing, just with the installation of the Helm, just adding the repo and entering the key GPG, and then just installing the Helm. Once Helm installation is done, this part is nothing, just adding the two your repositories. Then we are trying to search in that if that is properly added or not. And then in this command, we are just creating the name Prometheus namespace so that we can install this Prometheus community. Inside we have a Cube Prometheus stack, so we can install this Cube Prometheus stack in the Prometheus namespace. Okay, so I have uh, I wanted to show that in the video, but just mistakenly I have already like deployed that already. But I'm just quickly let me just quickly show you. Yes, if you see, I have just copied and ran all the commands together as I mentioned there, as I mentioned in the notes as well. You see it's just installing the Helm utility, and then sorry, downloading the key, then oh, sorry for this. Yes, and then it's just it installed the Helm first, and once the Helm is installed, you see the two of the repositories has been added. Then this we search this Prometheus community. You see this is searching here, and once this is searched, it's just the namespace is created, and once after that with the name of with the name stable, this cube Prometheus stack has been installed, and check its status, it's running. So this is the total installation of this. I hope it's very easy. So now what we have got in this, if you just I'm just going to just clear my screen. I'm just running the command kubectl get all. I'm running this on the master node and under the my Prometheus namespace. So if you see all these like resources were installed by just that one command. That's why this is a recommended way, and it is an easiest way as well. So now let me just take you to it basically installed like two stateful sets, then the three replica sets, the deployments, which is just under part of the deployment, and the replica sets are the part of deployment. Then there is one daemon set for the node exporter. Then we have several services. Then we have several pods which are like comes under the deployment as well as the stateful sets. Now let me just do one quick thing so that I'm just want to convert the cluster IP service to the node port, so that by the when I reach the explanation, it's already ready for us to check the portal. Let's see. So I'm just editing this service. I'm just changing its type to the node port so that I'll be able to access the portal. Same for the other one. So this is nothing. First one is for the Grafana, and second one is for the Prometheus UI. It's already done. If I just get all, you can see this both are already converted to the node port, but I'll use this. So first of all, I want to talk about the stateful sets, two stateful sets. So now so the two things. Now, what is a stateful set, and what is the difference between the stateful set and the deployments? So stateful apps, basically stateful sets are nothing. These are similar to the deployment, but it is used for the stateful applications. Now, what are stateful applications? Stateful applications, basically the application which maintains, or you can say that retains the state in the memory for the past interactions they had. Let's say if there is any user session, so they retains the interaction in the memory. On the other side, the stateless, which basically are deployments, they don't retain any such information. They just they just rely on the current request, and all the information which is present on the request at that time, they just relies on that. So what kind of applications are stateful? Let's say we are using any messaging system or any online gaming, or you can say any the NoSQL databases. So all those applications comes under the stateful. But for the stateless, you can say the microservices, maybe, or you can say any web servers or APIs, or yeah, or also and now that these are the basic difference between the stateful application and the stateless applications. So in this like all the resources which we are seeing here right now, the stateful, these two, one is the Prometheus. This is the major Prometheus application, like you can see the Prometheus server or the Prometheus stateful set, and the alert manager. So these two are the part of the stateful set, and in this there is a deployment. Yeah, the first, this is an operator. I already mentioned the operator is it's a way to manage the Prometheus individual components. So this is very important. It is basically managing all the communication between the stateful set and the deployments. And this is the deployment is this Grafana, which is the UI. UI to manage or to check the, we can run the PromQL queries on the Prometheus data. And this is the cube state matrix. This is also a very important thing. So this this chart which we deployed, this comes with a cube state matrix. This matrix is, this deployment is responsible for monitoring the Kubernetes, all the resources, all the components of the Kubernetes. I'll show you in a very good way in the Grafana. Okay, first I just wanna show you this, explain this stateful set. I already have the command ready so that we don't have to waste the time. Yeah, this the describe one. Yeah, if we see here in this stateful set, first of all, just the name and the namespace. I'm just gonna come. Yeah, so it basically has a init container. Init container is nothing, it's just a configuration reloader. So init containers are nothing. If you know Kubernetes, they are just like, they're just like containers. They are just there for a specific purpose. Like this, it just runs, it completed task, and then it just terminate. So right now this container is there to reload the config of, like, which config it's reloading. It's reloading the let's see where it is. Yeah, so just reloading the configurations. Like you can see, this is the config file, then we have the rules file, then we have the config file of the Prometheus. So this just one time reloading is a part of this init container. Then we have the other container. The first container is Prometheus. In this container, you can see it's running on the port 9090, and under these all are the arguments. Post which on the thing which I am interested here is the mounts. You can see that the certificates are mounted inside the container under this path. Then we have out config. Then we have the rules file. So this rules file is really important because this is read by our alert manager in this. Then we have our web config. Then this is, I believe this is the /Prometheus, which is, I believe, the scrap endpoint where we have all the data, and our retrieval worker retrieves data from this endpoint. And then we have this port. Now this is another container here, the config reloader. So this is also it's kind of a sidecar container. So we have two containers in this. So this is the image of this config. It is running on 8080. This is the command, and these are the arguments it is running. It also has a rules file, and yeah, this is the main file. It is reloading. So it's like a prometheus.yaml. Now how it is, like this is the config. This is mounting the etc Prometheus config from config. It is coming from the config. Now see what is this config. So inside the volume, if you see, this is the config, and this is okay. So this config is a secret. It's not the config maps. So it is stored as a secret here. And now let's see for the rules file. This rules file is basically, yeah, this, it's coming out of the from this, and which I believe is, yeah, this is a config map here. You see here. So let's check out what we have in this. I already actually copied the commands. So let's say let's get the first secret. So this is the secret for Prometheus.yaml. Yeah, you see, so this is the secret and this is the Prometheus.yaml. So this data is like base 64 encoded. Okay, if you want to, as I mentioned in my last video, if you want to monitor any endpoint, we have to mention that in the Prometheus.yaml. So this is the data. So first we have to, decrypt this data. We have to mention our secret or the configuration file. I mean, we have to decode this file, and then we have to mention our endpoint in this file, and we have to encode it, and then we have to place it as in the secret. So that's how it works. But if you want to check how does it looks like inside the container, I have already mentioned that command as well. I'm just executing on the container. Like if you see, so I have executed on the same pod in the namespace, and I have just run a command cat. So if you see here, this is the file. So this data, so this is actually this. So it's the same file we discussed in the last video, just the default file. In the global settings, we have the scrape interval and we have the evaluation interval. This interval is for to evaluate the rules. Evaluate the rules. Yeah. So it's the same file, everything. And in this part, we have to define our endpoint. And if we have to pass it in the secret as a secret, and then it will be in the pods. And we can get the other config map for the rules file as well. So this is the rules file, and yeah, these all are the rules which are already predefined. Let's say let me see the easiest ones. Yeah, so I think all the alerts are there. Prometheus not connected to alert managers. These are all the warnings. Yeah, this is the critical one. Prometheus SD refresh failure. So all these are the predefined alerts, like node network interface flapping, node network, like node bonding degraded. So all these are the predefined alerts available. Then we have the stateful set for the alert manager. Yeah, this is the other stateful set. I believe it would also be the same, just a different image. If you see, this also has an init container, which is just having an config reloader at the first time, and it is having on the multiple ports, running on the multiple ports. You can be just using this image, and the container this carries. Yeah, so this is the alert manager image is running on the multiple ports. First is the alert manager, and like these all the other arguments it possesses. Then we have the config reloader, the same. It is also, but this carries this time. This carries a different two mounts. The mounts are alert manager config and config out. So this basically has this config out is empty. It has nothing as of now, but this config is mapped as a secret this time. Config as a secret config volume. You see it here. Yes. So I believe, yes, you see the config out. It's an empty directory. So that's it. We just click on the get all. So these are discussed. We don't need to discuss the replica set, I believe, because these are just part of the deployments. In the deployments, this is just a Grafana deployment. Nothing, we don't need to worry about that. This operator deployment, as I already mentioned, it's just a way to manage the Prometheus individual components. So this is just there to monitor the Prometheus. So now this is we've already discussed. Now let's go to, so all these are just the pods. We don't need, these are all the services and these are the pods. So these two pods, I believe, are coming out from the stateful set, which is one is for the Prometheus, the main Prometheus, and one is for the alert manager. Then this pod is coming out of the Grafana. The very important thing, this thing is left, the daemon set. And I believe you see these are the two pods, and these two pods are for the node exporter. I'll tell you now what it is. And then we have the one for the cube state metrics. So this pod is there to monitor the Kubernetes cluster. So this is coming out of this deployment. The cube state metrics. Okay. Then the Grafana, and then this is for the operator Prometheus. This is for this deployment. Now one of the most interesting part is this daemon set. Now, if you know Kubernetes, you know the daemon set. Daemon set is it's like it's like a, you can say kind of a deployment which basically stays on all the nodes to monitor. If we need an application, let's say a monitoring application to be stay on all the nodes, okay, then we deploy that application as a daemon set on all the nodes. So that's why this is there is a node exporter, and it is deployed inside the daemon set. Now daemon set is automatically it deploys on all the nodes. And if we know the node exporter is, it basically monitors the hardware and the operating system, like the kernel and the operating system, and provide all the information to the Prometheus storage. And from there, we can run the PROM12 queries from the Grafana and from the Prometheus UI. So now let's quickly, don't wait. let's copy the port. This is the port. Let's go to the AWS. Let's get the IP of the master server. Thought 30692.30692. This is the Grafana. All right, this is. Then we have node port. Yeah, it's running on 9090. The Prometheus 30324. 0324. So this is the UI of Prometheus. This is Grafana. Now to get the Grafana password, either you can get the secret, like the prom. We have a yeah, just so all these things, like there are a lot of things which was deployed in this stack. Prometheus. Yeah, so there are a lot of like these configurations. These all are the config maps which were deployed by this Helm chart. It's not possible to discuss like all the config maps, but you can go through it, and like there are, as you can see, just this is for the rules, this is for the stable Grafana, and so right now, and same like the secrets, a lot of secrets were also deployed. You see all these secrets now. Now out of now one of the secret, I'm just getting the password using the JPath. You see this is just a secret Grafana, and I'm running a JSON path query on this data.admin password and decoding it to get the password. You see, so I've just got the password from operator. You can also get this password on the Helm website as well, the chart. So you see, this is just here, and we don't need the password for this. And this is the Prometheus. So this is the Prometheus UI. It's running on, we're just using it in node port with the public IP. And if you are like running this on the Minikube, you just need to forward the port for that. You can utilize the port forward command for with the help of kubectl. So now these all are the alerts. You see, I was telling at the time, I mean, when we were checking that the config map. Yes, so all these alerts are pre-configured, which comes with this chart. Then I think for the status, if we want to see, so for let's see one by one. So these all are the command line flags, which we can use. Current value is this, but if you want to use it on the command line, we can copy and use it from here. Then we have the configuration. So this is the file. This is the global conf. This is the current configuration. This is the Prometheus.yaml file. Like all, so these all are the alerting, alerting. These all are the rules. This is all coming out from the rule files. We have also seen that file, so you can see the configuration on this portal as well. But I'm just want to show you one thing in the last, like if you want to monitor job, let's say this is one of the job. So this is it, a job means the target which you are monitoring. Okay, so right now it's monitoring the stable Prometheus node exporter. If you see it here, it is exposing it, the data, it is scraping the data on the slash metrics, and all these are the part of it. I mean, this is just a formatting which is being done. So this is the configuration. Then if you want to see the rules, you can check the rules here one by one, and you can also get the labels here. Like a lot of rules are already present. Then the targets, yes, so these are the current targets which are currently being monitored. I mean, it's like this is the pod 244, as we know. This is the pod network. If we go more inside, you see this is endpoint 10 to 244 is the pod. It's a core DNS. STA API server, alert manager. Then if we go down this, now this is a metric. It means this is an internal IP of the VM, like 106. If we go here, one of yeah, you see this is one of 103, 106, sorry. Yes, so we can come here and check. Then these are the targets. Then the service discovery, like this is a mechanism to identify the target, what all the targets to monitor. So you can check it here. If you want to check the labels, you just click on the show more, and the multiple labels you can see it here based on the. Now on the Grafana, I mentioned that as of now we don't have any, external, let's say, an application or any other application to monitor. But this is currently monitoring the Kubernetes cluster. If we come here and we see the dashboards, like so, there are multiple dashboards which are already a part of it. Let's see the cube. Let's go for the pods. Okay, so this is the dashboard for the pods. So this is because we don't have much pods in this. Let's go for the Prometheus. You see here for all the pods, we have the data like memory utilization, CPU is there is no data. But if we, let's see, might have the in the cube system as well. You see, it's the memory 25%, and in the from the request from limits, there is no limit reached. So yeah, these all are the pods which are currently getting monitored. The CPU quota, the usage, the requests, then the memory usage, memory quota. So that's how detailed monitoring is done by the Prometheus. And all these in the backend, this Grafana is just sending the PromQL queries to get to fetch the latest information. So if we just go back to the Grafana, it's just sending the query to this PromQL, and this PromQL is the work. I mean this accepting the PromQL queries and sending this to storage, and from there, from this storage, this is sending a response back to the Grafana. So similarly, there are like multiple dashboards are available. You can like let's say let's go to you can networking pod like for all like node exporters. So these are two pods we have. So these are the nodes we have. One is the control plane and one is the worker node. Let's see for the 191. If you see this is the load, this is the CPU, memory usage, disk utilization, all the disk space, the disk mounted, network received, and network. So this is by default monitoring, which is available by this installation, by this deployment. I think that's it. That's all I want to show in this video. However, if you, yeah, there is one thing which I think there should be a part of it. I'm gonna make another video where I will I'll add a application, maybe a third party, let's say a MySQL or a MongoDB application should be how we can monitor that using the Prometheus, and they'll be visible through Grafana. So I'll make one more video on that, and I will make sure to add it. So thank you so much, guys. I would say please like subscribe this channel and for this kind of content. Thank you. Thank you. Bye bye.